Okay. Hello, everyone. Welcome to this session. Today, we're gonna see how a small introduction how you can build a machine learning model using TensorFlow. Machine learning model using TensorFlow to generate poetry. Even though it's not, the results are not great, but all the stuff you will get from here are just the general knowledge you can use to later to create natural language processing models. First of all, let me introduce myself. My name is Taha Bouhsine. I'm a data scientist and the GDSC lead of University of Nizar for this year, of course. Okay. Okay, let's look at presentation goals. First of all, these are the takeaways, what you will take with you after attending this session. The first thing you will take with you is getting, as I said, getting the basics of natural language processing and the basic steps to create a natural language solution with TensorFlow. Then a hands-on practice with TensorFlow to create models, general models. And the last thing is you will become the next Nizar Qabbani. So yeah, you will find, I will share with you the notebook I've created for this session, for specifically this session. It's a Kaggle notebook that I've created. I will share the links with you right now. It has all the stuff I will talk about during the session and a small implementation of natural language processing with TensorFlow. You can share it. Okay, so before starting the session, let's first get started with small motivation. Why are you interested in creating this model? Well, of course, before starting, anything I say here is obviously not based on a true story. It is a work of fiction, and any resemblance to real people is totally coincidental. And yeah, knowing that, as you know, the end of 2020 is near us, and as everyone is celebrating the new year, a person is all alone coding a machine learning solution for another year. But sadly enough, as far as machine learning has advanced, it is not enough yet for him to create a sentient AI to talk to. So that person, let's let him be unknown, wanted to connect to new people. And while at it, why not look for the faithful companion? So he decided to write a poem for this task, for the task of finding the faithful companion. But the problem is he sucks at writing poetry. But lucky enough, it just got certified as a TensorFlow developer, and he's a master of his craft. So during this session, I will walk you through the basics, all the basics you need to know to create a solution using TensorFlow for natural language processing problems, not necessarily only for generating poetry, but also for, I think, we will look at some application at the end of the session. You can use these basics to. So the data sets I'm going to use is the Arabic poetry dataset from Kaggle. It contains most of the poets from the 6th century to the 21st century to this day. I will send you the link of the presentation at the end of the session, which has all the references and also has the links to the datasets. Or if you've already entered the link I've previously shared with you, you can find the dataset in the data section. So just tune in. This dataset contains about 58 poems with all the extents from the 6th century to the present day. Along each poem, there is a metadata which has the poet name, the poem, the text of the poem, and its category, and also the title of the poem. But what we are interested in is the poet, the name of the poet, and there is about 600 poets, more or less 600 poets, and about 600 poets. It's written by 600 poets. But for our motivation, we will try to imitate the two of the poets existing in the dataset, which are Nizar Qabbani and Abu Nawas, because they are one of the. We are trying to imitate them. Nizar Qabbani has about, in this dataset, has about 605 poems. So we will try to filter and only keep the poems written by Nizar Qabbani and Abu Nawas. We can use data frame functionalities to do that, and by only keeping data, by only looking for the columns where the poet name is either Nizar Qabbani or Abu Nawas. For Nizar Qabbani, we have 600 poems, and for Abu Nawas, we have about 800 poems. And by when we combine these two conditions to get the data we need, so we will try to extract only 200 poems from the filtered data after shuffling it and with this simple method, with sample method we have there, and then we will get all the poems into a NumPy array. We'll keep only the poems without keeping the title of the poet, the name of the poet. We will try to put all those poems into a NumPy array. And then there is one problem in this data set. Each of those poems, we have I think we have there is some poems that contain some special characters or some non-Arabic characters, or about some HTML tags. And in order to remove them, we will use the following regular expression to iterate through all the poems and clean them and keep only the Arabic letters. Of course, it will add some noise into the poems, but for the sake of this small workshop, we will try to use only this, even though we need to do more cleaning to create a corpus. This is what we are trying to build, which is a large collection of text. And in the machine learning sense, a corpus can be thought of as a machine learning model's input data, the data that we give to our model to train on, which contains the text you want the model to learn from. And for our task, we will need all the poems to train on. And we don't need a validation set because we don't need to validate our model. We're just trying to make our model fit the poems we have and find the patterns that each word, what follows each word, and keep on training on those patterns to help us generate the poems we need. After building the corpus, we will try to tokenize it and create for each unique word, we try to create a token, which is simply given each word has a number in front of it, and then we'll try to build a dictionary of words and numbers. To do that, we will use the TensorFlow tokenizer from the Keras preprocessing, .text, and to help us build the word index we were just talking about by calling the fits on text on the corpus we have, and we'll try to put the length of this corpus into total words, because we will use it later for our model. And the tokens, if we were to print the tokens, we will find that each word, as I said, that each word has a number in it, and you will find them in the tokenized.word index dictionary. Then we will try to create sequences from the list of tokens we have by going through each of the poems and putting the word instead of the word. We will try to put a number. And it is important to understand how we will be handling our inputs, how our inputs data for our model. We will be dividing the inputs into chunks and sending these chunks through the model one at a time. The features for our model are simply the words we are interested in analyzing, as represented with the bag of words, of course, we talked about, or the corpus. The chunks that we divide the corpus into are going to be sequences of words. And you can think of every sequence as an individual training instance in traditional machine learning tasks. For that, we have to find the longest poem in our corpus to make all the sequences into a uniform length. Then we will try to pad those sequences that we just talked about into uniform with the length we just talked, and creates predictors and label. The predictors are the x's of the traditional machine learning, and the labels are the next word we are trying to predict. And we will use one-hot encoding to transform the numbers in the label into a one-hot vector, which is the process of this one-hot encoding refers to a method of representing text as a series of ones and zeros. A vector containing all possible words you are interested in, often all words in the corpus, is created, and a single word is represented by a one value in its representative positions. Meanwhile, all the other positions in the vector are given 0. A vector like this is created for every word in the feature set. And when the vectors are joined together, the result is a matrix that contains a binary representation of all the features of all the feature words. Why should we use one-hot encoding? One-hot encoding are useful when you need to create a bag of words or a representation of words, but that takes their frequency of occurrence into account. And then we'll move on to the model we will try to use. What we are trying to create is a model that's for word level generation. It's not letter generation, not letter level generation. It's a word level generation task that takes as input a sequence and try to look for the word, not take a sequence of letters, but it takes the words of the corpus. Then for that, we will use the model, the sequential from TensorFlow Keras models, and we will first start by an embedding layer, and then we will try to use a bidirectional LSCM, and at the end we will have as the final layer will be a simple dance model that has the total of words that we calculated here. I think here, yeah, the total words we calculated here, which contains all the number of words in our corpus. Use it as an output layer, to use as a one-hot encoding layer. And the activation, for the activation, we have softmax activation, and by using the softmax activation, so we will try to use categorical cross entropy, the loss of categorical cross entropy, and I will be using the optimizer Adam, and the metrics I will be using to keep track of the progress of our model. The history of our model is the accuracy. So what is what is word embedding? That's I've used here, the embedded layer that I've used here. Word embedded refers to the representing words or phrases as vector or real number, just like one-hot encoding. But for word embedding, it can use more numbers than simply ones and zeros we saw in one-hot encoding, and therefore it can form more complex representation. For instance, the vector that represents a word can now be comprised of decimal values like 0.5. This representation can store important information about words like relationship to other words, their morphology, and their context, and etc. Then we will use the bidirectional LSCM, or LSCM, which is a network that are specific type of recurrent neural network, and have the advantages over all the other recurrent neural networks. While it's recurrent neural network can usually remember the previous words in a sentence, their ability to preserve the context of earlier inputs decreases over time. For the model history, we try to plot it this way. We can see that as the training goes along, it does quite good. It reaches about 0.90%. And this is the time for some poetry. We will try to use the model we built to generate some kind of poems we try to build. First, we will try to the seeded text we will use is this one. It's just some random words we will try to use, and we'll try to generate about 200 a poem with 200 words in it. And for that, we'll try to use this function, which is just a for loop. We will try to input a sequence and generate a new word, then pass that sequence to the end of the new sequence we'll try, and feed it again to the model to generate a new sequence. Then we'll try to repeat it for 200 times to generate about 200 words. First of all, we try to put the seeded text we got here and the seeded text we got here. We will try to sequence it using the text to sequence from the tokenizer. And then we'll try to pad the sequence to be to have the max length, the max sequence length we've calculated previously, and have the same length as all the inputs we had. And then we try to call the model.predicts and calculate the np.argmax on it, and try to look for the word in the word index we previously, if there is the word in the previous word index which we built previously. We'll try to look for the word predicted if there is the mathematical corpus. If not, we will try to skip it. And then we will try to concatenate the output word with the seeded text we have previously. And the results are this, which is quite ugly, to be honest. It's not something to be proud of. But if we were to split each, look at the patterns we have, I think there is some kind of, it's the same text. It just, I've tried to look for kafia and keep it going till I didn't find anything. So this is the poem that our model has built, and the other part of the poem is this. And yeah, you can see how he's trying to mix between three kinds of poems of Abu Nawas after looking for abiyats in Google. I found that there is different verses from different poems of Abu Nawas, and it's such a poetry, but sadly enough, it's not that good, to be honest. It's not that good. It's just for fun and just for learning some new stuff, and it's just to learn the basics of natural language processing, which is quite nice. And well, too sad for us. We won't be spending the new year with anyone because of COVID, of course, and maybe next year, inshallah. So for the challenges in Arabic, not like the other languages, the Arabic language is quite complex and it's rich. So by just using the word embedding or any other encoding method, we find ourselves quite saturated and quite limited by the resources we have, because just in Arabic you can have three words that have the same, that are the same word but that have شكل مختلف. Donc so it's not practical to create something like that without firstly trying to clean the data and try it them in different ways. It has an ambiguous structure, as I said, and there are different types of Arabic or dialects, and for the advanced models that you can use to create the same solution for the stack, and even better solutions, you can use the GPT-2 model, or you can use the GAN architecture, or you can use the LSCM CNN for this task. And by learning the same stuff we've talked about today, you can use the same knowledge we have talked about in DNA sequencing with machine learning to classify the DNA of a virus. Is it a virus? Is not a virus, or something like that? You can use the same knowledge we talked about in text translations to translate Arabic to French or to English or something like that. And you can use it to generate new drugs like they've previously used. All this application I'm talking about are already available on for in practice. It's not something in academic or something like that, but there is some actual work in the industry world. I think this is all from me. Do you have any questions? Okay. Do you have any questions? Thank you very much. Yes, this session will be recorded. A lot of questions. Well, okay, you can start by one. Feel free to ask if you have any questions. I will be glad to answer them. We still have too much time. Okay, to improve the prediction, we can use delete some of the unuseful words and try to. It's not by using more resources, but it's just by improving the data we already have got on our hand. If you look at the data the data sets we used, it's not that good. It has some limits. Like I didn't. You can't find when. Well, usually you feed just a verse by a verse to the model. It's not. You don't feed the whole whole poem to the model. By feeding the whole poem to the model, it's kind of overfits on the poem. So just by when the model starts to predict the word, the next word, just by starting a whole verse of some specific poem, it continues on generating the same poem over and over again. So one step to improve this model specifically, I think it's by just feeding the model one verse at a time, and trying to look at the generation. It's not so. It's just yeah. There are other limits like the quality of the also I think the quality of the data, as there are some data sets that has too much. It's not cleaned enough because there is some kind of French into Arabic and some English into Arabic, which is not that good. So it's again a question of the quality of data. I hope I answered your question. Amin. Welcome. Hi, Mustafa. Okay, if you don't have any questions, I think this is end of this session. Attention mechanism can help us in this case. Yeah, that's why I've used the LSCM model, which is also it has some kind of attention mechanism, and that's why the GPT and GANs are quite useful for this specific the task of generating new data from already existing one. But I think it's not okay. It's not that practical without a clean data. Again, going back to the data. That's why there is the data-driven decisions. PR. Any other questions? Okay, if you don't have any other questions, I think this is it for me. In the presentation, I will share with you the presentation. Just a minute. You can find all the resources and references I've used for this presentation. And you can also, welcome. And you can also look at the collab I've used for this. Okay, let me check. Okay, I send it to you. Yeah, okay. So thank you very much, everyone, for tuning in. And Taha was with you. Feel free to contact me if you have any questions about the stuff I've talked about, or any questions about machine learning. Thank you very much for GDG MENA for hosting us. And see you again. Bye.